Well, again, we're going to be multiplying rational expressions, and what I want to do is put this in two parts, not because I think it really needs two parts that much, but there's another type of example to do. Now we're going to multiply these out and simplify them. Before I get started with that though, let me do a problem right here. Very quick problem, no x's, no variables, and see if you can do this. So I got 2/4 times 3/6. And I show this problem before I do multiplying rational expressions. Say, okay, solve this. And students get a little nervous and flustered and they say, don't you cross multiply? I'm like, well, you cross cancel, not cross multiply, cross cancel. But another way to do it is very simple. You can do this. 2 times 3 is 6. 2 times 3 is 6. 4 times 6 is 24. 6 over 24 reduces to a fourth. Bam. Finito. Duh. Here's another way to do it. You cross cancel, and what I mean by that is you can you cancel out terms, not cross multiply. You just simplify what you can. You can do 2 divided by 4 or 2 divided by 6. Let's do 2 divided by 6. How many 2's fit in the 6? 1. How many 2's? How many 2's fit in the 2? 1. How many 2's fit in the 6? 3. Oh, 3 divided by 3. That's 1. Bam. Okay. 1 times 1 is 1. 4 times 1 is 4. Same answer, different approach to do it. You know, I like this way much better because it's easier for me, but I've noticed that students don't feel comfortable with that, so they say, oh, I just want to do this, and then I'm going to try to divide and reduce it each time. I'll divide by 2 and it's 3 over 12. Then I'll divide by 3 and it's 1/4. And you can do that too, that's perfectly fine. But pick your poison there. Personally, I like it that way better. So let's see how to do this first one. I've got 2x squared over 3x times 6x squared over 12x cubed. And what you can do is you can start factoring. Not factoring, pardon me, cross-canceling. I would recommend that you don't cross-cancel the variables, and I'll just show you a really quick reason why I don't think you should. So here we go. I've got, I can cross-cancel the 2 and the 12, the 6 and the 12, the 3 and the 6. It doesn't matter. What I find generally is more helpful for students is not cross-canceling because then they can keep track of it easier. I don't know why, it just is. So here we go. 2 times 6, 12. 3 times 12, 36. X squared times x squared, x to the 4th. X to the 1st times x to the 3rd, x to the 4th. Now, if I ask a student what 12 divided by 36 is, they're going to tell me 3. No, 36 divided by 12 is 3. So 12 divided by 36 is the reciprocal, it's 1/3. You know, you just go like this, and you just write your 3 going up that way instead of that way. X to the 4th divided by x to the 4th is 1. 1/3. Bam. Not so bad. With these types of problems, it's a lot more difficult. You can't just cross-cancel, and you're like, oh, I'm going to cross-cancel it. No, you can't do that. This has 2 terms and this has 2 terms, but they're not exactly the same. This has 3 terms and this has 3 terms, but they're not exactly the same. What you have to do in order to do this is factor. Either with the GCF, you always check GCF first, and then you start factoring the binomials. So I have 3x squared plus 3x. What can I take out of both terms? I can take a 3 and an x out. Now if I divide this one by 3x, I've got x. If I divide this one by 3x, I got 1. Careful, lots of students don't put anything down. If you don't believe me, check it. 3x times x, 3x squared. 3x times 1 is 3x. What can I take out of a 4x squared, 24x, and 36 if there's anything? The answer is 4. When I take out a 4, I've got x squared, subtract 6x, plus 9. Oof. I don't like this one. Times, I can't take anything out in terms of the GCF, but I can definitely factor. Negative, negative, x and x. What times what is 3, but adds up to be negative 4? Negative 3, negative 1. Then, what can I take out of an x squared and an x? I can divide out an x, but x squared divided by x is x. Negative x divided by x is negative 1. Now, I'm not actually done factoring. And, I thought we were done. No, we're not. Because I can factor this. What times what is a positive but adds up to be a negative? It's a negative and a negative. What times what is x squared? X and x. What times what is 9 but adds up to negative 6? It's 3 and 3. Times this is where my students really like this. And I say, you know, you can kind of consider this like, you know, fighting back the problems that you never really liked in math. I'm going to go ahead and erase this while you take a gander at that, because I need some room. And what I tell my students is, this is like, you know, a math problem picking on you. And what you can do is you can get your revenge. And at first students, I don't know what they think, but sometimes I hear them saying this as they're doing this. Maybe it's just like a cue recall psychology trick. They might get it faster. Anyways, back to what I was going to say. I say what you do is you can cross cancel. Now, this is like, you know, a problem that treated you very poorly, and you can take your revenge. You can say, you can cross cancel, you can go like, I hate you, you know, figure out what you can woo, figure out what you can cancel. And like, okay, is there another x minus 3 somewhere? Yes. And you're like, alright, this problem is much better. Okay, there's no x plus 1, you kind of get disappointed. And there's no other x minus 3, so you know you can't cancel that. But you can cancel this 3x and this x because they're both one term on one term. Whoosh, whoosh. Yeah, this problem's not so tough anymore. And what you have left is you have a 3. I'm going to write my answer here. And you have an x plus 1 over, you have 4. You have an x minus 3. And you factor that monstrosity. Now most problems probably don't require that type of, level of factoring, but I think it's pretty cool that you had to use the GCF 1, 2, 3 times, and then you had to factor in 2 binomials twice, and then you got to cross cancel. Okay, we're going to do another example of multiplying rational expressions. It's just a little different, and sometimes students find it confusing. So it's good to kind of go over it and see how it goes. But until then, have a good day. Bye.